Ready to apply it? Okay. Okay. All right. Before we do anything else, we're going to practice our graphing by hand. I want you to take a minute or 3, and I want you to graph r equals 3 cosine 2 theta from 0 to 2 pi, the whole graph accurately. You're going to need to, when I had some students in first who just jumped in and just plugged in 0, pi halves, pi, and 3 pi halves and thought they could get a graph, it's not going to work. You're going to have to do all the little angles in between.
Did you say by hand?
It is very possible you will have to graph polar equations by hand on your test.
What is it?
Your test is after the AP exam.
Okay, 3 years from now. Yeah. Shakes her head.
Wait, do you want us to polar?
Polar. Yep, this is polar. Polar coordinate plane. So I would go start at 0, then go to pi 6, then go to pi 4ths, then go to pi 3rds, then go to pi halves, right? I would plug all those little angles in. Once you get from 0 to pi, you could probably finish it off using symmetry, kind of figure it out. But try and see.
So 1/2.
Me, Ron, 2K2. Kind of weird, dude. We really need some drawers here because I don't have any of them. Okay, so 5 what comes after 5 over 6? It's reduced. So 3 root 3 over 2. No, wait, because it's times 2.
No, issue.
Oh,
Issue 5.
so this is 0. I 6.
No, it's over.
Oh, this is
5. 4 pi.
2 pi over 3. It'd be 0. Because it's 5.
No.
Okay, so then 2 pi over 3.
What's the angle after
No,
5?
1 just do that? Or it'd be 1
What's the equal to pi halves? 2 pi 3rds.
Okay, so much.
Oh, yeah.
So pi halves.
I did it.
Okay, so now it's
So it's negative 3.
4 pi.
3 pi 4ths.
3.
No, we're doing multiplied by 2.
Oh, you're plugging in.
Yeah.
As you go. Okay.
So 4 pi, which is,
1.
so
Negative 3.
cosine is going to be negative.
So it'd be
Negative 1/2.
it should be negative 3.
Right?
Negative 3 halves because you're times by 3.
Yeah, we had
Plus
got
3, so negative 3.
Yep.
and then it's 3 pi.
These are kind of
That's just
6 pi over 4.
I think they just want to be symmetrical. Can I graph it on my calculator just to check?
Yes.
Yeah.
And then now,
I think they just end up being the same.
no, 2 pi. I mean,
No,
no,
it's
there's
six.
six.
Whatever you follow last year. So 10 5 over 6. 5 5 over 3.
Which is it?
I think it's.
No, from 4. 5 5 over 3.
Yeah, because that's right before.
So it's 1 half. And then
How high do we have to go? How high did you guys go?
we were not even in pi yet.
This is what it should look like.
Whoa, I don't think I did that.
Oh, we can just go to pi, so we're on pi.
Wait, maybe it is.
5 pi over 6.
No, is it the pi rule? So that'd be 2, negative 2 pi over 2. It would be over here.
Wait, we don't need to make other lines.
That's the first half.
Should be half.
Do like one more point.
You're not saying part of 0.
Yeah, we kind of do like ties and like.
Exactly.
It should be negative.
Start graphing, just kind of start following your graph. So start at 0 for me.
And then
Okay.
pi over 6 halves 1.6.
It's like a little curve, yeah.
4,
It seems right. Like,
0.
yeah, because we have the points right.
3,
Now, you're missing,
or 1 over.
let's see. Oh, wait. This should be a negative,
Pi
right?
over 2, negative.
Pi thirds. If you plug in,
Oh,
you get 2
yeah.
pi thirds. Yeah.
And then
No, that's okay. So you still graph it, but the point's gonna be. Yes. Except it's a pi thirds, that's pi. That would be negative pi thirds. Bless you.
wait.
Oh, I think I got it. Wait, but how would I know that it was a certain thing? So,
Okay, and then
how would I know how to connect the dots?
Well, you gotta follow them in order.
5 pi over 6.
So you were at, wait, you were at 0. Your next point is pi thirds, negative 3 halves. So from 0, you go to that point down there, yeah? The next point is pi halves, negative 3.
Wait, you follow them, did you follow them in
And
order?
follow them in order.
Okay.
So start at 3,
There's negative 3 halves.
5,
Good. Now you're at 0. Very good.
That's all we have. I can get my vote.
Now you're 5 pi 6, not 3 halves.
wait, it goes to 0. I think I'll just do it over 3.
Yep.
I know where it's like.
Figure out where you're gonna go next. All right, I'm seeing some good graphs.
Have these always been here?
If you did it right, you should get a rose,
Don't roses have more petals?
okay?
Yep.
So don't roses have what? Roses have, if this number is odd, it's the number of petals of the rose. If this number is even, it's twice, this is half the number of petals of the rose. The rose will have twice that many petals, right?
So if it was 3, it would have 3 petals.
It would have 3 petals. Yep. So you have a lovely 4-petal rose. All right, now the question says find the tangents at the pole. To find tangents at the pole, the theorem says if r is 0 and r prime is not 0, then theta equals that value is a tangent at the pole. So the first part of the theorem says if r is 0, so how would we start? Let's set r equal to 0 and find the values, which you should have in the list you just made, right? So you could probably just look at your t-chart and figure out where is r 0 for what angles.
It's all of the pi over 4.
I shouldn't make the 16. I'm gonna check for your keyboard.
You always follow in order. Yeah. No, it doesn't.
Oh, see, I've never.
Here's my.
Just Google it.
Which makes it very good.
Good try, good try. I don't think we quite made it, but.
All right. Quiet, please. So, did you get all the pi fourths as your zeros? Okay. Now that's showing where r is 0, but now we got to check if r prime is not 0. You do not have to find dy dx. You literally just have to find r prime of theta, right? So everyone take a second and find r prime of theta.
0.
No, not at the angles, at literally the equation.
-6 sine.
That's really not.
theta.
Yeah.
Yeah,
Is this supposed to be in perfect rows?
Yeah, I'm too much obligation to just keep having people that.
Oh, if you zoom in.
My account.
So once you find your r prime, plug in any of your pi fourths and tell me if you would get 0 for any of them.
No.
No, you never get 0. So as long as r is 0 and r prime is not 0, then these are all tangent lines at the pole. All right? However, there's more. But wait. Okay, if I were to graph theta equals pi fourths, theta equals pi fourths is a line going in both directions like that. Because it includes positive and negative values of r, right? So that's theta equals pi fourths. If I graph theta equals 3 pi fourths, I get this line. So it does look like they're tangent, right? If I drew them not off, but you know, you get it, right? Okay, if I graph theta equals 5 pi fourths, I'm right back on top of the theta equals pi fourths line. And if I graph theta equals 7 pi fourths, I'm right on top of the 3 pi fourths line. So technically, there's only 2 tangent lines, so you really should only give the 2 equations so that you're not being redundant, right? So there's our 4 tangent lines, but really, since we have equivalency, really these are the only actual 2 answers. How's that sitting?
I assume.
This is telling me after today I'm learning that we need some more practice with basic trig and with polar.
Yeah.
Okay.
And derivatives.
And basic derivatives, yes.
Integration, all of
In integration and related rates.